our topic is equation of family of planes. Family of planes through the intersection of two planes. See, first of all, you have to visualize it, how the two planes intersect. Let us see this GeoGebra graph. Given plane, red and black are a given plane, and you can see that these two planes, they do intersect along a line. There is a line of intersection of the two planes. Now, through this line of intersection of the planes, how many planes can pass through? You can imagine the planes which is passing through the line of intersection of the black plane and the red plane, and you can visualize it now, children. This green plane is also passing through the intersection of the two planes, black and red, blue, yellow, green, everything. You can just visualize that. We are given two planes. There is a black plane and our red plane. Black and red plane are given, and there is a line of intersection of this black and red plane, and through the line of intersection of the two planes there can be infinitely many planes passing through. I have just shown 4 planes passing through the line of intersection, which is given with the green, violet, and yellow and all. Okay, all these planes are passing through. Now today's our topic is to find the equation representing all these family of planes passing through the line of intersection of two planes. I think now we can visualize it. So let us go. So we are given two planes. Let the two planes be as ax plus by plus cz plus d equal to 0. Let be the first plane. As all of you know that the first degree equation in xyz represents a plane in 3D geometry. And what does this ABCD stands for? That also you have learned that this A, B and C are the direction ratio of normal to the plane. If there is a normal, as you know that normal means is a line perpendicular to the plane, and the direction ratio of the normal is A, B, C. Now, we are given two planes, right? So let the second line be AX, the same AX you cannot take. So the second line be capital AX plus BY plus CZ plus D equal to 0. Let it be equation number 2. Then these two lines, let them intersect through a line, and the family of planes passing through the line of intersection of 1 and 2 is given by the first equation ax plus by plus cz plus d plus lambda times the second equation. Second equation means here it is, we have assumed as it is ax plus by plus cz plus d equal to 0. You can even Just simplify and write also. That is, we can write it as, considering the two x terms together, you can write it as a plus lambda a into x plus b plus lambda b into y plus c plus lambda c into z plus d plus lambda d is equal to 0. In other words, we can say that first equation, if it is first one is line is L1 and the second line is L2, then the family of first plane is L1 and second plane is L2, then the family of planes you get as L1 plus lambda times L2. That is a linear combination. What you say, lambda times you are adding, you are telling that it's a linear combination of the two equations is equal to 0. That is an easy way to remember this. Now in this family of planes we'll have the coefficient of xyz as the coefficient of xyz, as usual, it is the direction ratio of normal to the plane. Okay, so now if you are just taking an equation, find the first number one, find the plane through the line of intersection of to the line of intersection of x minus 2y plus 3z plus 4 equal to 0, and the second one is x minus y plus z plus 3 equal to 0, and parallel to x-axis. So here when you are getting this question, first to analyze the question, find the plane through the line of intersection. So we have to get equation of a plane. When you have to get an equation of a plane, see this plane whose equation to be found, we call it as the required plane. What it is? It is a required plane. We can just call it as the required plane. And the required plane satisfy many conditions. As per the question, it satisfy first condition that it is through the intersection of these two planes. One condition. And another condition is, what is the other condition? It is parallel to x-axis. So by taking these two conditions into consideration, the procedure is you can assume the equation of the plane. While you assume the equation of the plane, you can consider any one of the given conditions also. So assuming the plane by taking one of the conditions given in the question, which is the easiest one, is we have two conditions, and the easiest one is the first one. That is, it is passing through the intersection of these two. There is a direct formula to write the family of planes passing through the intersection of two planes. So the first condition can be taken into account while you assume the equation of required plane. After assuming the equation of required plane, then you apply the next condition on the assumed plane. Okay. So what you can write now is, let the required plane be we are given two equations. So the first one plus lambda times the second one. That will be the equation of family of planes. Our plane is also passing through the line of intersection. So one member from the family of planes will be our required plane. So we can assume the required plane as the first equation of the given plane plus lambda times the second plane, that is x minus y plus z plus 3 equal to 0. So this is assumed. This is our required plane. So you can also see that any plane wherever we assume or given, this plane will be a first degree equation in x, y, z. So there will be one x term, one y term and one z term. So now it need to be rearranged as one x term, one y term and one z term and one constant term. So you can see that there are two terms of x. Two terms of x. Combine it together, x plus lambda x. So what will get? Combining 1 plus lambda times x plus. Again, you take two y terms. So when you take two y terms, what you get as coefficient of y as 2 minus, here you have to multiply and get 2 minus lambda y plus. There are two z terms. So while you are combining these two z terms, 3z, then plus lambda z and z is taken out. So you'll get 3 plus lambda z, then plus combine the constant terms, you get 4 plus 3 lambda equal to 0. So this is our required plane, just rearranged only. Now let us just visualize it. This plane is parallel to x-axis. Okay, so I have taken this plane as the red color plane. So you can see that this plane is parallel to x-axis. Now how do we apply this condition that this plane is parallel to x-axis? So here is your red color axis, that is your x-axis, and our plane is parallel. And it is also to be noted that any plane which when you consider, you have to think in terms of its normal. Okay, how can you take a normal to this plane? Taking a point on the plane. You can see that this normal, you can see the normal, yellow color line is our normal to the plane. Immediately you convert, think in terms of normal and x-axis. Because here you are given that the plane is parallel to x-axis. Now you think about its normal, how it behaves with x-axis. You can see that x-axis is your red color axis, and even another normal also we can consider children. Another normal I am taking this. So there are many normals. You can see that this, when you are given that the plane is parallel to x-axis, you immediately convert the plane in terms of its normal. So when plane is parallel to x-axis, you can see the red color axis is x-axis. Red color axis is x-axis. Plane is parallel to x-axis. Then normal is perpendicular to x-axis. The normal is perpendicular to x-axis. Now we can visualize it. Plane is parallel to x-axis. Then normal is perpendicular to x-axis. Now, when this plane is parallel, this was a plane we have shown in red color and it is perpendicular to x-axis. So what is the condition of perpendicularity of two lines? You have studied when two lines are there, condition of perpendicularity. For that you consider the direction ratio A1, B1, C1 of the first line and direction ratio A2, B2, C2 of the second line, and if the two lines are perpendicular, then we have the formula, that is A1 into A2 plus B1 into B2, B1 into B2 plus C1 into C2 is equal to 0. So this condition only we will apply wherever the perpendicularity condition comes. So what do we have to write next? Next we will just see that our required plane 1 is perpendicular to x-axis. So 1 is parallel to x-axis as per given, implies that normal of the plane 1 or the required plane 1 is perpendicular to x-axis, which I have shown you in the GeoGebra graph. So now we need to write the perpendicularity condition. For writing the perpendicularity conditions, you have to write the direction normal and also the direction ratio of the x-axis. So what is the direction ratio of the normal? So direction ratio of normal, that is, we know that the coefficient of xyz, so it is 1 plus lambda, then 2 minus lambda, and 3 plus lambda. Similarly, we know the direction ratio of x-axis. Direction ratio of x-axis, you know x-axis ka direction ratio is 1, 0, 0. Since the normal is perpendicular to the x-axis, we can apply the formula A1, A2 plus B1, B2 plus C1, C2 is equal to 0. And what is A1, B1, C1? These are A1, B1, C1, and this is A2, B2, C2. So when you apply this, you directly multiply and write. Okay, directly multiply and write. A1 into A2 means 1 into 1 plus lambda. So we can write directly as 1 plus lambda plus B1, B2. It is 0 into this plus C1, C2. 0 into this. So you will get 0 plus 0 equal to 0, or that means we are getting the value of lambda as minus 1. Once if you get the value of lambda, we can find the equation of our required plane. This was the equation which I have assumed. Therefore, the required plane is, putting the value of lambda in this equation, you will get the required plane. So therefore, the required plane is 1 plus, your question you can see that is 1 plus lambda into x. So you're getting 1 plus minus 1 into x plus 2 minus lambda into y. 2 minus lambda, that is 2 minus lambda, it is minus 1 into y plus, what is the next coefficient of z is 3 plus lambda into z. So what you get here, it is 3 plus minus 1 into z plus the constant of 4 plus 3 lambda. So that becomes 4 plus 3 into minus 1, that is equal to 0. And you can see that your answer is, here it is 2 plus 1, that is 3y, then plus 2z plus 1 equal to 0 is the equation of the required plane. Thank you and have a nice day.